Okay. Good morning, everyone. I'm Stephen Okuta, and today we are going to study geography, and our topic of today will be on minerals and rocks. Now, before we start looking at the minerals and the rocks, we'll first look at the background on how the earth was formed. So number one way in which the earth was formed has been proposed by several theories. The first theory was proposed by one scholar who gave a theory of the passing star theory. So the passing star theory insinuates that a large star passed through the sun, and a part of it melted and later cooled down to form the current planets that we have. And the second one was the passing cloud theory, whereby a whirling gas moved around and later settled, and when they cooled down, they form the current planets that we have right now. So that's how the current planets were formed. Now, the reason why we want to talk about rocks is that it forms the basis of the formation of soil and the current things that, be it economic, be it social, be it political, acts on it. So number one thing that we look at is how are these rocks formed and how are the minerals formed as a result of the current planet that we have. So number one that you are going to look is that these rocks were formed as a result of the formation of the earth, in which formed the three parts. So the earth is divided into three. We have the crust, which is the upper part of the earth. Then we have the middle part, which is the mantle, and then the last part, or we normally call it the inner part, which is the core. So the core is divided into two. There's a solid part and there's a liquid part. The solid part is found at the center, and when you travel from the surface to the inner core, it covers around 6,378 kilometers for you to reach at the center of the core, and that is the center of the earth. The second one is the mantle. So the mantle is also divided into two. There's a part called the upper part and the lower part. So the upper part composed of a mineral called siol. Siol is an abbreviation of silica and aluminum. Then the other part is sima, which is silica and magnesium. So those are the two. The other part is the mantle, which is on the topmost layer of the earth. But because of the environmental processes, the movement of the environmental processes or the earth processes like volcanicity, plate tectonic movements, and the eruption of the magma into the earth's surface has led to the formation of several landforms. So it is these landforms that are either disintegrated or eroded to form the part of the soil that we see. And in other words, we say soil is formed from the parent rock, which can either be chemically formed, physically formed, or can either be formed through other processes. So number one thing that we look at are the terminologies that are used. The terminologies that are used in this topic. So number one, we have crystallization. Crystallization refers to the way in which magma that erupts into the surface or that erupts beneath the Earth's surface and forms some elements. So when they form these elements, they can be formed either by cooling fast or by cooling slowly. So in this process, it forms what we call the crystal. So the process of the cooling of the magma that has erupted from the mantle part forms what we call crystal. And it's this crystal that is formed as a result of crystallization. Then the second one is erosion and sedimentation. So erosion naturally refers to the wearing of the rocks or the wearing of the parent material. After wearing it, they can either be washed by the agents of erosion, which can include water, ice, or by gravity. So when this is formed, they lead to the formation of what we call the sediments. So it is these sediments that are formed, and the ones that are either washed away by ice, water, or by physical means. So this process is called sedimentation. And then this last part, which is called metamorphism. So metamorphism is a process that is formed under two things. Number one is the pressure. Then number two is the heat. Sometimes we call it the thermodynamic. So it is the changes in pressure, intense or extreme pressure, and heat that leads to the heating of the existing minerals to form another component. So that's how metamorphism acts, and we'll see how they lead to the formation of metamorphic rocks. Now let's start by looking at what a mineral is. So a mineral can be defined as organic or inorganic substance which occur naturally on or beneath the Earth's surface. So these elements, as I've explained to you earlier, is that they can be formed naturally. And they can be formed naturally and can be deposited beneath the Earth's surface or on the Earth's surface. So the part that they're either deposited or on top or in is the crust part. So that is the mineral. So this mineral, the mineral can have definite what we call it can have a definite chemical composition or inorganic substance, or physical properties. So this chemical composition or physical properties contains elements like we have oxygen, we have silicon, we have aluminum, iron, calcium, magnesium, sodium, potassium, titanium, and carbon. So these are the physical or chemical properties that minerals are, and we'll discuss these characteristics and see how the properties of the mineral works. Whereas the rock is a substance that is formed as a result of the mixture of the minerals. So the rocks are formed as a result of the mixture of the minerals. Now let's look at the characteristics of the minerals that we have. So number one thing that we'll focus on is on the hardness. So different minerals have different resistance to abrasion and scratching. So this is the intensity that some minerals can either be soft or hard. So these minerals, they have different degrees of hardness, and some can easily be broken and some cannot. Also, another characteristic that you should look at is the shape. The shape of the minerals differ from one mineral to another. For example, the shape of diamond is different from the shape of graphite. So different elements have different shapes. Different minerals have what we call ability to allow light to pass through them. So different elements can either reflect, some cannot reflect, depending on the color that they have. And this brings us to The other characteristics, which is color, different elements or minerals have different colors. So for example, when graphite is black, you can get diamond is shiny. So all the minerals that we have don't share the same color, but they don't share the same color, but they reflect different properties in terms of color, and this color comes as a result of the making, the composition of the making in that element, in that mineral. Then we have cleavage. This is the tendency of the mineral to break along the plane of weak bonding. So some elements, when broken, they tend to break along the line of the bonding. And this is the line that wax has a weak point. So they are likely to break at that. And for that, for instance, we have a mineral called mica. Mica, it can break in a form of a thin flat sheet, while granite can break in granules. So these are different types of the intensity or the type of minerals that can pose different characteristics that are not common to each other. Then we have fracture. Some also have what you call the line of weakness, which is different from the bonding part. So this line of weakness, for example, we have quartz, which has no cleavage. It has no cleavage because for it to break, it works with what we call the lines of weakness, while others will work with the lines of bonding. This color, for example, this color these minerals can be rubbed, or they can be brushed against each other, and they can leave different residues depending on what they're made of. Others have what we call distinct shapes. Minerals possesses different distinct shapes, and that you can see the shape. For those who have done chemistry or have been introduced to chemistry, you've seen different minerals or elements possesses different types of the shapes that they have. So this should be cleared and shown on how these minerals works in terms of shape and the type of bonding that they have, so as to give them the shapes that they have. So we also have the appearance and quality, as I'd explained about the ability of these minerals to reflect the light. And I've indicated that some minerals are dull, and therefore they cannot reflect enough light that can illuminate the light well. So let's look at rocks. Let us now look at rocks. Now, rock is a mixture of the minerals. It is formed as a result of the mixture of the minerals. So when different minerals are collected together, the grains are held together to form a solid mass. So this is the solid mass that leads to the formation of the rock. Now, different rocks, different colors and textures seen in this rock are caused by presence of different minerals. So how does it work? We can clearly define that any type of rock that is formed depends on which minerals makes it. So for example, when you want to talk about different rocks that are formed, then we'll have to look at the process at which led to the formation of these rocks. So rocks can primarily be contained in their texture, and each type of rock has a distinctive set of minerals, meaning each type of rock is formed by different sets of minerals. Now, when we look at this, for example, we have sample 1 and sample 2. So sample 1, we have the mineral, then we have the texture, the formation, and the rock type. In the mineral, sample 1, in the mineral, we have plagioclase, we have quartz, we have hornblende, and we have pyroxene. So these are the minerals that form sample 1. Then the texture they give out is what we call the crystal visible to the naked eye. It is crystal visible to the naked eye. Then the formation. It is formed as a result of the magma that cooled slowly. It is formed as a result of the magma that cooled slowly. And this leads to the formation of a rock type that is called diorite. Then the sample 2, we have plagioclase, then we have hornblende and pyroxene. That is the same mineral. But now the texture is crystals, and they are tiny in microscopic. They are smaller. Then the formation, the magma that cooled and the magma that erupted and cooled quickly. It leads to the formation of a rock type called the andesite. So you can see, depending on the level at which magma cooled, the one that cooled faster led to the formation of the andesite, and the one that cooled slowly led to the formation of diorite. So the table above shows the same chemical composition, and they contain mostly the same mineral, but they do not have the same texture. They don't have the same texture because the level at which these two materials were formed was as a result of, number one, the magma that cooled faster or quickly, and the other one that cooled slowly. So this leads to the formation of different textures, and therefore it gives us different types of rocks which have the same minerals. Now, let's look at the classification of rocks to their mode of formation. So rocks are classified to the way they were formed. And the first category that we are going to look at are the igneous rocks. So igneous rocks form from the cooling of magma. And when it erupts into the Earth's surface, it's called lava. So when magma erupts into the Earth's surface, it forms what you call a lava. So the lava is a chemical composition that cools, and when it cools, it determines the rock that it forms. So as the mineral cools and crystallize, it forms what you call the igneous rocks. So igneous rocks are also formed as a result of two types. Number one, there is rocks that are formed as a result of intrusive igneous rocks. So, and another one is the one that is formed as a result of extrusive igneous rocks. So the intrusive igneous rocks, these are magma that erupts, but they don't reach the surface of the earth or the crust. Rather, they cooled and they crystallize underneath the earth's surface. So when they cool, they form what you call the intrusive igneous rocks. And some of these structures, the rocks that have been given, somehow they have been referred to as plutonic structures. These are structures or rock structures or rock materials that are formed as a result of cooling of the magma before it reaches the surface of the earth. So these rocks, as I've told you, they're called plutonic rocks, and they are deep-rooted. Examples include granites, we have diorite, we have peridotite, we have gabbros, and syenite. Now, the extrusive rocks or extrusive igneous rocks, these are rocks that are formed on the earth crust. They are formed on because the magma reaches, erupts out on the Earth's surface and cools. So when it cools, it forms what we call the extrusive rocks. So these rocks, they cool very fast. They cool very fast, and they're often referred to as the volcanic rocks. They're always referred to as the volcanic rocks. And example of these are the hypabyssal rocks. So these rocks were formed as a result of the gradual cooling, the cooling that takes place slowly on the Earth's surface. And these rocks are shallow in depth as compared to the plutonic rocks, which we've said that they are cooled underneath the Earth's surface, and once they cool there, they are deep-rooted because they never got to reach on the surface of the crust. Now, these rocks have tendency of showing different the pH level. So the pH level is the acidity or the alkalinity level. So when when magma erupts into the Earth's surface, and it shows a substantive level of the silica. Therefore, this kind of rocks tend to have the pH that is lower than 7, meaning it's acidic. But the ones that have low level of silica, they tend to have a pH of more than 7, which is alkaline. So we should differentiate that the level of silica gives the pH of, or the acidity or the alkalinity level of the rock substance. Now, let's look at the characteristics of the igneous rocks. And we'll start looking at how the igneous rocks are textured. So textures, the texture of the rocks vary from one to another. So the igneous rocks, they normally are generally light in weight, and their color are somehow dull. The igneous rocks, such as the basalt, have what we call the vesicular texture. Vesicular texture, this means it has a lot of porous or holes that was formed as a result of the magma which cooled, but still holes were left behind because of the slow cooling of the process, and therefore lots of air escaped and passed through the cooling magma. So when it cools, it forms what we call the vesicular texture, as shown in that picture. And then we have another category which is called the rocks that is formed as a result of fragments or individual fragments. So when it wraps and then splits into smaller pieces, so it is these smaller pieces that later solidifies, and when it solidifies, it forms what we call the pyroclastic texture. The pyroclastic texture, as shown in that picture. And then there's another characteristics which it has. It contains mineral called silica. And as I've told you, the higher the level of the silica, the higher the likelihood of a rock to be acidic. And that is vice versa to the rocks that have low silica level, which are basic in nature. So some rocks also have different surfaces, which some might be rough, some might be smooth, depending on how they are formed, and again, the agents that acted on them. And we've said the agents act as a result of weathering, which can be chemical, which can also be biological. It can also be physical. Now, the other category of the rock that we have is the sedimentary rocks. These are the sedimentary rocks. So sedimentary rocks form part of compaction and cementing. So in other words, sedimentary rocks are a collection of rocks that are carried to a certain level from one point to another, and then they sediment. Now, to explain this better, rocks which have sedimented creates what we call layers. So the first layer, when the first bunch of the granules or the sediments, as I explained to you, these are materials that are withdrawn from the parent rock material. So when these materials are taken to another point, for example, in Kenya here, we have mountains, we have valleys. So those those grounds that are in higher level, they tend to erode. So when they erode, these sediments are taken down the hill and they are settled. So once they settle, another form that acts on them is what we call the compaction. There's a force of compaction. So when they are compacted together, they form a rock. And so each layer that comes to each other is distinct to another, is distinct from one another. And in that, they form some kind of layers that people can count. And this has also been useful to archaeologists in knowing the age of environment or the age of an area, whereby they're able to use what we call relative dating method, which means they use as old as. They use the word as old as in knowing at which level was this land formed, how the process ended up there, the composition from the materials of the rocks were withdrawn from, and also the process, or they can calculate the level at which the erosion was occurring. So this is very important for dating because it can give the age of certain environment due to sedimentation. So you said once these sediments have moved down the hill, they are compacted together to form the sedimentary rocks. And you can see, besides the sedimentary rocks how they are formed, we have an area that is overburdened up there. And then we have a few samples of the rocks that have been formed. We have quartz, we have feldspar, and we have phosphate. So once they go to the process of compaction, it leads to what we call the cementation. So once the rocks have been cemented, it forms the sedimentary rocks. So in other words, sedimentary rocks have formed as a result of the sediments that have been compacted together. So this can either be transported through land, it can be through sea, and it can be through wind or ice. And a good example you can see the formation of the Kariandusi site that we see right now. There is diatomite. Diatomite has been formed as it has been formed as a result of compassion. Different minerals that have been moved within the sea, and these animals, they call diatoms, the ones that died. So once they die, they form what you call the diatomite. So once they die, they call what you call diatoms. And that's why we say probably our Rift Valley, at one point it was covered by water, because the diatoms can only live in an area that is covered by water, so an area under sea. So that's why we say probably Kariandusi or the entire Rift Valley could have been be covered by water before the change of the environment. So example of sedimentary rocks, they can either be formed in two forms. Number one, there is organically formed. So there are those rocks that are formed. So when rocks accumulate, when they accumulate what we call the dead plants and the animals, so these organisms, once they are accumulated for a period of a long time, they lead to the formation of the coal, the charcoal, and I've talked of diatomite that is at Kariandusi, and the precious commodity that we people are fighting for right now, that is oil, coal. These things have been formed, has been formed as a result of sedimentation. So the organic materials, when they decay, especially the remains of the plants and the animals, when they decay, they lead to the formation of the coal, the formation of the chalk, the diatomite, and also limestone. So when rocks, these rocks that are organically formed can further be divided into three parts. These ones that are formed as a result of calcareous process. So these are rocks that are rich in calcium. And then the other one is ferruginous rocks, which are rich in iron. So from your chemistry, again, you have seen that from the word Fe, so this is a name that is given to iron. So all those rocks that are formed as a result of the ferruginous process, they have rocks that are rich in iron. And then we have siliceous rocks, and which are formed as a result of the sedimentation of silica. And we've said that silica is the one that determines the acidity and the alkalinity of the rock material. So that is another one. So there's also another one which is carbonaceous rocks. So these carbonaceous rocks are rocks which are rich in carbon. And where do you get carbon? Carbon can be, they can be found in plants, they can be found in dead plants, they can be found in animals, and they can also be found in the living things. Now, the other category is chemically formed sedimentary rocks. So these are rocks that are formed as a result of what we call precipitation. So what is precipitation? For all those who have also been acquainted with how the mineral works or the chemical works, is that the chemically formed rocks as a result of precipitation, this is a process that involves once a component or a mixture or a compound, let's say a compound, water evaporates, it leaves what you call the residues. So it is these residues that forms what you call the precipitates, and it is these precipitates that forms the rocks that you see. And that's why we say they're chemically formed. So when they're chemically formed, they lead to the formation of rocks such as the carbonates, the sulfates, the chlorides, the silicates, and the ironstone. So example of these rocks that we can talk about are the carbonates, travertine. There is dolotomite and trona, soda ash, which is found in the areas around Magadi, and you know its uses. We also have sulfate and gypsum. It's also very, very important, which is used in making of sculptures. We have chloride rock salts. We have silicates, flints. We have hailstone, the limonite, then hematite. So these are rocks that are formed as a result of chemically sedimentary rocks, in that after the precipitation, it leaves the precipitates, which leads to the compaction of the residues that forms the rocks that you are seeing. Let's look at the characteristics of the sedimentary rocks. The characteristics of the sedimentary rocks. There are two main characteristics of sedimentary rocks. One characteristic is that it occurs in layers or strata. It occurs in layers or strata. And to show you this, it occurs this way. Assuming that this is our hill, and this is the downhill. So once erosion has occurred here, the sediments are taken down. So when they're taken down, the first sediments will be compacted to form the first layer. Then the second batch will also be coming. So when it comes, it forms another layer. So you can differentiate the older layer and the older layer and the earlier layer by looking at the first sediments that were compacted first. And this is what I told you, the strata, which the archaeologists can use in measuring the age of this particular area, because they'll be counting the layers at which they appear, and secondly, look at the rate of erosion and then calculate how it was formed and how long it took. And therefore, they'll give what we call a relative date, meaning that they'll use that point A is older than point B because point A came first. Now, the other part that we are remaining with is what we call some sedimentary rocks that contains the remains of the living organism. So we said the first part is the layers that are formed as a result of the cemented. Once they're cemented together and they form layers, that is one characteristic. And the second characteristic is the sedimentary rocks that contains living organisms. And this is what you said forms the formation of the petroleum, the gas, the coal, and the chalk. Now, when you look at the picture, you'll see the rocks that have been formed, the rock structure that has been formed in layers, and the other one is the earth that shows the decay of the living organisms. We have a fish there that decays, and over a million of years, it leads to the formation of coal. And the last one is the metamorphic rock. And when we are beginning this lesson, we indicated that the metamorphic rocks are formed as a result of metamorphism. So the metamorphism, I've said that is the process of intense heat and pressure. In other words, we call it the thermodynamic process or thermodynamic process that leads to the formation or that led to the intense heat and pressure impacted on the existing rocks to form another kind of materials. So especially when it works with the igneous rocks or the rocks that contains minerals and are heated together, they form different things. For example, if you take element A, you combine it with element B, and then you put them under intense heat and pressure, it results to the formation of an element C. These rocks are also known as changed rocks because they change as a result of heating. Their characteristics involve the process of heating, which leads to the changing. Then the other ones depends mainly on the originated materials. In other words, metamorphosis rocks depends on the igneous rocks or the sedimentary rocks heated together and put under intense pressure to form another rock. Their texture is always, their textures is normally generalized because when one element is heated, with one element is heated containing a mineral to another one, leads to the formation of another element that can either be of different size depending on which material was used to heat the existing materials. So looking at that, we've now analyzed and see that different rocks have formed as a result of three things: the igneous rocks, which occurs as a result of the molten rocks cooled beneath or on the surface of the crust of the earth. Then number two, sedimentation rocks, which are formed as a result of the sediments that have been eroded to form another layer of the rocks. And then the third one is metamorphized rocks, which are formed as a result of intense heating and pressure, which gives us different types of rocks. So when you're given this question to tackle, you must know that these key three things leads to the formation of the rock that is from the parent rock material. So class, and for those who are watching me at home, I'm very grateful for this opportunity. I hope you'll take care of what I've given you and make sure you stay safe, stay at home, and be careful. Thank you so much.